What's up, it's your boy the Canologist. We're going to be doing another episode of Programming Study Sesh and OSRS AFK training, mainly because I have to trade up my account in order to do a bunch of these quests. So while I do that, we may as well just do productive work. Why generics? Okay, so reduce repetitive code. Reduces repetitive code. They're used often in libraries and packages. So you should care about generics because you don't have to write as much code. It'd be frustrating to write the same logic over and over. Utility packages. My eyes itchy from allergies. Libraries and packages contain importable code. Why did it take so long to get generics? Go has an emphasis on simplicity. So basically, Golang just didn't have generics because they didn't want to make. They only had the bare minimum. Unlike C, they kind of it's like a redo of C except with all the essentials only. So they just make sure everything they add is exactly what's needed. Which code would be most likely to help with? Would generics be most likely to help with a binary tree? No. Calculating the area of a circle? No. Detecting whether or not a string contains a given substring? Well, this isn't generic. Calculating area of a circle. Well, yeah, it would just be area. Oh no. Is it a binary tree? Oh no. Okay, so let's figure out why a binary tree is the reason. Only deals with strings, only deals with circles, yeah. Strings, integers, oh okay, I see. I was thinking of something completely different. You can use a binary tree with values that contain both, I guess. Go's approach to language design. Never add new features. Well, resist adding new features unless they're extremely important. That makes sense. Generics will probably be used more heavily in, not main, but library packages. Because library packages are imports. Constraints. Shit, my eyes are actually itchy. I don't know why. Sometimes you need your generic function to know something about the types it operates on. The example we used, the first exercise, didn't need to know anything about the types. So we used built-in any constraint. Constraints are just interfaces that allow us to write generics that only operate within the constraints of that interface. Any constraint is the same as the empty interface because it means type in question could be anything, okay? Creating a custom constraint. Look at the example of a concat function. It takes a slice of values and concatenates the values into a string. T-stringer. This should work with any type that can represent itself as a string. Even if it's not a string under the hood, okay, so user can have a dot string that returns a string with the username and age. I mean, this is the concept of generics. So I guess. So let's analyze the code. Okay, so we have a type stringer interface. So we're creating our interface here. We're telling the program. And then string. So now concat's gonna have type stringer. The function signature is going to be vals, so of type T. So it's going to be generic array and returns type string. So now we go through each of the values in that array. This is where the dot string method is used. That's why we need a way more specific constraint instead of the any constraint. Why do we need this? Okay, so now we're going concatenation string vals T result. So we're basically creating a string, concatenating it, I guess. Concat takes the range of values and combines them as a string. Typecast these values into a string and adds them to result. We have different kinds of line items that we charge our customers credit cards for. Line items can be things like subscriptions or one-time payments for email usage. So this is a generic, it looks like. Oh no, this is a non-generic. This is the interface. T, line item. So new item T, this is generic, old items T, balance float. Okay, so we get an array float 64 and an error. I'm thinking. This is errors, FMT, and time. So let's go step by step through this function. And then it says check if the user has a balance with enough funds to be able to pay for the new item. Okay, so check if the user has enough funds. New item, old item. If they don't, then return insufficient funds error and 0 values for the other returns. Okay, so basically I'll just do an anti. Sweet. 57 wood cutting. Okay, so type T is line item. I've created a generic, so get cost. Is greater than the balance, which is a float 64. Let's do what it says. If it's not greater, yeah, so you go not A, B, basically. If they don't return an insufficient funds error, so let's return an error. If they do have enough funds, add the item to the user's history by appending the new item of the slice to the slice of old items. Let me guess, this is T, and then this T is string. Get name string, subscription, one-time usage plan. They have a bunch of different functions here, so we're just going to use whatever they've provided. Since old items is already defined, we have to go append old items. We have to list the array we're changing, then add the new item, then I have to get the name. So .get name .get calculate the user's new balance by subtracting the cost of the new item from their balance. Oh yeah, I have to also return nil for these, so that's what I'm gonna do. And then what's the return? The slice, float 64 at error. So the slice float 64 at error, so the slice is old items. Float 64 is the balance, and error is this. So I'll do this. I'll call this error. Just because I want a clean return statement, so the person reading this can match it to the function signature. So the slice is old items. Which is a generic type slice. Then we go balance. Oh, and 0 values for the return values. Okay, so let's go. Balance and error. I believe those are the nil values. And then in this case, it's going to be old items because it worked. Balance. And then nil for the error because there's no error. This should work. Unexpected comma. I mean, it returns 3 items in the signature here, so syntax error, unexpected comma, expected type. Oh, old items. If they don't return an insufficient funds, and 0 values for the other returned values. So this is 0 value. Okay, let's go check with boots. Maybe it's a syntax error I'm not seeing. Oh, do I have to return this as a bracket? No. Let's see this. Oh, I need to declare this variable. Type in the empty slice when you return. Go needs to know what type of elements. Return an empty slice of type T. Okay, so we actually have to do a formal creation of an empty slice. Oh, it's a capital. Get cost. I was looking at get cost in lower. So I'm like learning the syntax from Boots while I do this. Now let's look at the running error. New item.getCost defined. The line item interface you see in main.go. There we go. The bird nest is worth 5K. You grasp core concept beautifully. In the charge for line item, T line item function signature, T is a parameter, is a type parameter. T is a placeholder for any concrete type. Line item is a constraint for T. This means that T could be any type that implements the line item interface. T could be any interface. Because T is constrained by the line item, we're guaranteed that any new item, which is a type T, will have methods define the interface. This is why you can tell okay. So yeah, we'll continue this in the next video where we explore these generics quiz questions. Peace out.